circles. You guys have all worked with the equations of circles before. Last year in geometry, in section 10.7, you guys all were introduced to the first time seeing H and K. You did this last year. You know the equations of the circles. But again, today we're just going to center them at the origin. We're not going to do any shift to them. We're going to do a couple of quick, very easy problems as far as writing the equation in this standard form. We're going to write the equation of a tangent line through a specific point, and that's about it. There's not much involved within circles. That being said, that's going to allow us a little bit of time to get the tests back to you guys and then talk about those as well. So, circles. Again, everything we do today is just going to be centered at the origin. No H, no K. So what we're looking at here is basically the following. A circle, center at the origin, there's my radius. Don't worry about it, Morgan. I got a screwdriver in the office I'll use.
Pretty sure that's a weapon. Got it.
The screwdriver? Can be.
If you're smart enough.
Again, the equation of the circle is nothing more than x squared plus y squared is r squared.
Isn't that just the Pythagorean theorem?
It is just the Pythagorean theorem because there's no shift. Also, you notice it's the same thing we did when we had to find the evaluate the 6 trig functions back in chapter 13, given an ordered pair. You use that x and the y to find your r value, and you wrote out sine, cosines, and tangents, and all that other stuff. So this x squared plus y squared equals r squared is nothing new to you guys. When we get into this, again, it's so unbelievably straightforward. I want to graph today. I'm not going to give you any graph paper. There's no need to graph this on paper. It doesn't have to be that fancy. If I have the equation y squared equals 25 minus x squared, it's very close to being in what they call standard form of a circle equation. I have to add x squared. Very good. All right. Now, when I add x squared to the other side, does it matter if it goes in front of the y squared or can it be behind the y squared?
It has to go in front.
It doesn't matter.
Oh.
I know. I think the sarcasm was there. So now I'm in standard form. Bless you.
Where are the freshmen?
So you have x squared plus y squared is 25. What's your radius? 5. Radius here is going to be 5. So when you go to graph this, again, this is centered at the origin. Nothing fancy. Take a deep breath. Am I just plotting the radius on the quadrantals? Does that work?
Oh, that's so easy. Oh, maybe. Wait, we don't have to draw anything. Oh.
Because aren't the quadrantals, doesn't that give you the radius? Yep.
Well, you have it when it's not 0, 0.
Yeah, we will.
No,
We'll get there. And you've done that before too. Again, it's not going to be that bad. Even if I said your center's at 3, -2, you could walk 5 spots on a piece of graph paper. So, when we're looking at these again, the craziest thing you may see, the craziest thing you might see is that your r squared term might be 10. So that means your radius is the square root of 10. I know, but I'm sure you could probably fit that here. Okay.
Could you draw lines on the SpongeBob where?
I've never watched that.
What?
Ever. My children don't watch that. I'm glad my children don't watch
Why?
that.
You're missing out.
No, no.
Don't be glad they don't watch that. It's not like it's a bad show.
I know, but I just don't really want it. So let's go a little fancier. Let's say the point 1,4 is on the circle. The center of the circle is at 0, 0. What is the equation of the circle? Again, the center of the circle is at 0, 0. The point 1,4 is on the circle. What's the equation of the circle? Well, what's the generic? What do you think?
Oh.
Isn't the generic form of the circle, since there's no shift, x squared plus y squared is r squared? What's x and y?
1, 4.
What's 1 squared?
1.
What's 4 squared?
16.
What's 1 plus 16?
17.
Okay, so 17 is r squared. Do I need to take the square root of that for the generic form of the equation?
Yes.
Richie's shaking his head no. Why?
Oh, not as a generic.
After it's generic, it's just the equation, it's not the answer.
But you need to define r. You need to take the square root so you can find r, not r squared, right?
What's the generic form of the equation?
X squared plus y squared equals r squared.
So do I need to take the square root of it?
No.
No.
Alright then.
So you just draw a circle around that point.
Nope, all it said is write the equation. X squared plus y
Oh.
squared is
Then why'd you draw a
17.
graph?
Just to show you what you were doing. Again, do you need to draw graphs for these? No. Does it help with visual representation of what you're doing? Yeah. So I know that there's a circle out there. That has the radius of the square root of 17.
Then you can find out.
It's very nice.
Yeah, the other one looks like a lemon.
Again, deranged potato. Again, this stuff is ridiculously simple. Okay, you guys should have absolutely no issues with this. The scariest part of all of this comes down to this problem right here. When we talk about tangent lines. Do you guys remember what it means to be tangent to a circle?
It's against so it's perpendicular to the radius.
Good. So it touches the circle at one spot.
A single point.
It touches it at one spot on the circle, and it's perpendicular to the radius. So if I want to write the equation of the line that is tangent to the circle, the equation of the circle is x squared plus y squared equals 13. And at the point, we'll say it's 2, 3 is where it's tangent. And like Dylan said, this forms the perpendicular line. That means we have to do a little bit of work. If I'm looking at that, in order to write equations of lines that wind up being perpendicular, you have to know something about their slopes. One of those above. All right? In this case here, I need to worry about the slope of the So, what are the two sets of ordered pairs that we have with the that deal with the radius?
0, 0, 2,
0, 0, and 2, 3. So, is 0, 0 really do anything for us? So, what is the slope of
2/3.
wrong?
Dang it.
3,
3,
2.
2, y over x.
Remember, slope is the change in y over change in x. If one of my ordered pairs is 0, 0, that means the slope of this radius, oops, the slope of the radius here
What's the
is 3 over 2. What's that?
please? I can't see the yellow.
The slope of that line is 3 over 2. Change in y over change in x. 3 minus 0 over 2 minus 0. Okay. So if the original slope is 3 over 2, what's the perpendicular slope? Very good. Negative 2/3 is my perpendicular slope. So there's my perpendicular slope. What ordered pair do I need to get that to go through? That one. Which one? 2, 3. How do we write equations of lines given a point and a slope? Point slope form. Again, point slope form becomes your best friend. It's something you guys have all worked with numerous times throughout the course of the school year. Substitute in your values, you wind up with y minus 3 is your slope, negative 2/3, times x minus 2. Distribute. Excuse me. We get y minus 3 is negative 2/3 x plus 4/3. And then lastly, I have to add the 3 over. Now, when we're dealing with these fractions, and we've done a lot of work lately with fractions, you know, talking like with the unit circle and all that, we got pretty good at adding common denominators real fast. If I'm going to add to 4/3, What am I going to change the 3 into?
9/3.
Very good, 9/3. So what's 4 plus 9? So my final answer is y equals -2/3 x plus 13/3. Okay? That's as tricky as this stuff gets. Bear in mind, when we get to all the shifting, when there is going to be an h and a k involved, you will have to actually find the slope between 2 points instead of a point and 0, 0. It's a little bit easier that way. Okay? Questions? Want you to do another one very similar to this while I give back some stuff to you real quick. Again, this is write the equation that's tangent to 1. Okay? Same basic thing, but the ordered pair now is 2, 1.
It's for me.
Gonna behave